Welcome, algebra students. Please make sure that you have your note packet open to page 21 to follow along with this video. If it's going too fast, you need to pause. Feel free to pause the video and we'll get started now. Today our goal is to graph quadratic equations and solve a system of quadratic equations, or maybe a quadratic and a linear equation, to find out what ordered pairs make both equations true at the same time. You should remember that from earlier in the year, this will look like intersection points on the graph. We're going to start by graphing the first quadratic equation on the left side of your note page here. So make sure that you found your note page and that you're open to this particular problem. Again, it should be on page 21. Let's graph. So this is in standard form. I don't need to check whether it's dotted or solid because it's not an inequality, it's just an equation. What I want to find first is probably the axis of symmetry. The axis of symmetry is that imaginary vertical line that passes through the vertex. And we have a formula or an equation to find that axis of symmetry, which is the equation of a vertical line, which should be x equals, and it should be negative b over 2 times a, where we're using the coefficients a, b, and c. Remember, a is the leading coefficient, b is the linear term coefficient, and c is that constant term there. So negative b over 2a in this case would be negative 6 divided by 2 times a positive 1. Well, of course, a negative 6 is a positive 6. 2 times 1 is 2, and 6 divided by 2 is 3. So the axis of symmetry for that first quadratic equation is positive 3. So I put that on the graph. X equals positive 3 is the axis of symmetry. After I find the axis of symmetry, I want to find the vertex. And you should remember from Unit 8, to find the vertex, I just plug the axis of symmetry into the equation for x. So I'm finding the y value, and y is equal to x squared. What's x in this case? X would be the 3 from the axis of symmetry. 3 squared minus 6 times 3 plus another 6. Of course, by the order of operations, I need to square the 3. That would be 9. Negative 6 times 3 would be negative 18 plus 6. Well, 9 minus 18 is negative 9 plus 6. That's negative 3. So my vertex is at 3, negative 3. Let's put that on the graph, 3, negative 3. Now, I can go ahead and make a table here. I know I'm kind of running out of room, so I'll make a table underneath the graph, which has 3 columns, x, y, a times y, negative 2, negative 1, 0, 1, and 2, 4, 1, 0, 1, 4. And then I multiply by a. The a value is 1. So 1 times 4, 1 times 1, 1 times 0, 1 times 1, 1 times 4. Cross those out. Now I have the ordered pairs to graph from my vertex. 2 over 4 up, 1 over 1 up, 0, 0, 1, 1, 1, 4. And if I wanted to go further, I could. I could go 3 over up 9, 1, 2, 3, 4, 5, 6, 7, 8, 9. Select that over. Again, I don't need to make this solid or dotted because it's an equation, so it's always going to be solid. There's my parabola. Now, the harder part of this problem might be actually just graphing this line, because it's been a very long time since we've graphed a line. This line is in what we call slope-intercept form, m times x plus b. Okay? The m is the slope, which is the rise over the run. And remember, I spelt it wrong on purpose to remind you that you have the difference of y's divided by the difference in x's, run. Right? Now, in this case, what's m? It's 1. So my slope would be 1 over 1 up. What's my b value? It's negative 4. Well, negative 4, the b value, is the y-intercept. So actually the y-coordinate of the y-intercept. So where is this blue graph going to intercept the y-axis? Well, the y-intercept is 0, -4 because of this b value. So I put that there. Again, my slope is 1. As a fraction, that's 1 divided by 1. So I'm going to rise 1, run 1, rise 1, run 1, and so on. And now I have this line. If you have a ruler, and if you don't have a ruler, feel free to grab one from the bin on the side of the room. I'm just going to give you a second to do that. So if you're waiting to get a ruler from the other side of the room, that's fine. Take my sweet time here to let you get a ruler. Now I have a line. Now again, at the very beginning of this, I should have told you, or you heard me say that the intersection points would be the solutions of this system of equations. And you can see that the graph clearly intersects some points on this other graph, right here and right there. There are two solutions. What are the solutions? Well, what is the ordered pair? 2, -2 would be the first solution. It's the x and y that would make both equations true at the same time. This other one would be 5, 1. Those are the two solutions that make this system true. Now that takes a whole lot of time. And obviously, it's important to know how to graph parabolas and how to graph lines. But you have calculators now, and they're called graphing calculators. Did you ever wonder why we call them graphing calculators? Well, guess what? It's because they graph. So you could see that this took a while to graph it by hand. And I can still graph this other one by hand also. But we have a calculator to help us. So I'm going to show you the steps on how to solve using a graphing calculator. This is a big day in algebra class. We're going to learn to graph on the graphing calculator. So the first step is, of course, to turn your calculator on. Make sure that it's on and ready to go. If you're in some other screen, make sure you hit second quit to get back to this screen where you start, where you can type in things. But I don't want to do anything on this screen itself. What I want to do is press the Y1 button. You should see that it's up in the top left corner here. I'm at Y1. I'm going to get rid of that quick. Now you see that I have all these Y equals menus. Y sub 1, Y subscript 1, Y subscript 2. And these are just the numbers of different functions that you can graph on your graphing calculator. And you can see that more clearly on the bigger screen there. If I go over to this particular problem, I have two functions, y equals x plus 2 squared minus 4 and y equals -x. Now you can graph these using your graphing calculator. So I'll use the left parentheses, x plus 2. You see where the x button was? It's right by this green alpha. And the second button, there's x. That's how I got that. Then I have to square that. The squared button, I believe, is this one. And then -4. And you see how I've typed it into the graphing calculator exactly as it's written, except that this one has a y subscript 1. So I'm going to put a subscript 1 on my function as well. And I'm going to make this other one a subscript 2. And I'm going to type in that into my graphing calculator as well. The negative button, you can't use minus. Don't use the minus key. I need a negative button, x. And guess what? Now all I have to do, there's a button that tells us that we can just graph right here where my cursor is. And I'll hit graph. And you see how my graph looks kind of strange? My y-axis is up here, my x-axis is over there. I'm going to go ahead and change my window to make it look nicer. So normally if I go to a window, it'll tell you what the x minimum value is, the smallest x value, the maximum x value, the scale you want the x's to go by, the smallest y value, the biggest y value, and the scale you want it to go by. I usually make my graph -10 as the smallest graph on the x-axis and +10 is the biggest number. I want to go by ones. I'm going to do the same thing for the y's. If I hit graph now, there it is, a parabola and a line, exactly what I would expect. Now it's worth noting that the blue line is here and the red parabola is there. Now you can see by looking at the screen where this graph seems to intersect, but it's hard to know exactly where that happens. Well, again, lucky for you, we can find exactly where those points are by using something called the intersection key. So now, once I've graphed the equations, if I hit second and I go to calculate, You see the blue text on top of the trace button where my cursor is? It says calculate. If I hit the second button, oh, whoa, what happened there? Second, calculate, and now I'm in the calculate menu. So second, calculate. There's an intersection button. Do you see that? Number 5. I can either scroll down and hit enter, or I can just hit the number 5 and it'll work. Now it asks you for the first curve. A curve is one of the graphs, and so you can cycle between the graphs by using the up and down button. You see on the top left of the screen, I'm changing from Y1 to Y2. I'm going to let Y1 be the first curve. I'm going to hit enter. I'm going to have Y2 be the second curve. I'll hit enter. It says to guess. Now I can move my cursor left and right to guess where I think it intersects. Do you see on the screen where my little X cursor is blinking? I can move it closer to where I think it's intersecting. I think it's intersecting right at 0, 0. So I'll hit enter. And sure enough, the intersection is at 0 on the X and 0 on the Y. So know for sure that one answer to this equation is 0, 0. That's one answer to this system. That would make both these equations true at the same time. There's obviously another intersection point though. So now I'm going to hit second calc again, go down to hit 5, which is intersection. I'll select the first curve as Y1, the second curve as Y2, and then I'm going to move my cursor all the way over with the left arrow to where it intersects about, right there. Let's guess. -5, +5. That's the other intersection point. -5 on the X, +5 on the Y. And so there you have it. Your graphing calculator can do this for you. Now on page 24 of your packet, so page 24, there are instructions on everything that I just did. So if for some reason you didn't catch all that, or if I was going too fast, there are instructions on page 24 of your green packet to help guide you through this process. But you can see that this ends up being a lot faster than graphing by hand. I can graph this one by hand just to show you that the calculator works. Let's go Y1, let's go in the red spot. The nice part about this quadratic equation, it's in vertex form, so I can get the vertex right away. And that makes graphing much easier. It's the opposite of the inside, -2, same sign as the outside, -4. So -2, -4. I'm making a table, my A value is 1, so the table is also very easy. -2, -1, 0, 1, 2, 4, 1, 0, 1, 4. So 2 over, 4 up, 1 over, 1 up, and so on. Oh, I went too far up though, it looks like. I apologize for that. Let's just fix that real quick. Then if I go 1 more over, I go 9 up. And now here's my parabola. And again, to graph the line that's blue, I have y equals mx plus b, where m is the slope and b is the y-intercept. I have -1x plus 0. So my y-intercept is 0, 0. My slope is -1, which means for every 1 I go over, I go down 1. So start at 0, 0. That's my y-intercept. 1 over, 1 down. If I go backwards, 1 over, 1 up. I'll use my ruler again. Connect the dots. I want to make my ruler a little longer, so I'll do that. Wish you could do that too, huh? So then I'm going to go ahead and connect the dots as best as I can. I want to move this up maybe just a hair. There we go. Now I'll connect the dots. And you can see clearly that the calculator was right. Where did the graphs intersect? The graphs intersect at -5, 5 and 0, 0. But the calculator got that much more quickly than we did. Let's go ahead and do that one more time to finish the video. Now notice that these graphs aren't necessarily super nice. So I have to solve for y first on this graph. I have x minus y equals -2. If I subtract x over to the other side, I get -y equals -x minus 2. If I divide everything by -1, now I have it solved for y, and y equals x plus 2. And so now I can graph these both in my graphing calculator. So go here, and then just clear those out by hitting the clear button. So I got y equals clear, then I have, looks like 1/2, or I'm sorry, y equals x plus 2, so x plus 2. And the other one was 1/2, so 0.5, x plus 2 squared. Now if I hit graph, it'll show up here. And then you could use the intersection key to figure out the intersection